Okay, let's get started. Hi, everyone. Thank you so much for joining our webinar today on the topic of how AppsFlyer reduced analytics costs. My name is Eran. I'm a marketing director at Upsolver, and I'll be hosting the event today. We have with us Ori, the CEO of Upsolver, John Williams from Amazon Web Services, and Avner Livne from AppsFlyer. Just a few housekeeping notes before we get started. If you have any questions during the session, just pop them in the chat and we'll get to them at the end. The session will be recorded and the recording will be available immediately after the session or maybe tomorrow. Yeah, that's pretty much it. We'll start with a quick intro by Ori, and then we will hand it over to the other speakers. Yeah, these are our speakers today. It's Avner, team lead at AppsFlyer, Ori Rafael, is the CEO at Upsolver, and John Williams, global head of agency business development at Amazon Web Services. Yeah, Ori, I'm handing it over to you. You can go ahead.
Thank you very much, Eran, and thank you, John and Avner, for joining us for this webinar. I think I wanted to start just by letting you know what Upsolver is, if you haven't heard about this before. Upsolver started kind of from us trying to scratch our own personal itch. We're working on a very large, very high scale data problem, also in advertising, by the way. And we were very frustrated by how long it takes us to do stuff with a data lake compared to a database. We have been working with databases for many years, and suddenly the same work I could do in 3 hours, I was doing in 30 days, and I need to find the data engineer that are super hard to find and are very expensive and waste their time writing ETLs for us. So Upsolver started as a project for just accelerating our internal work over S3. Until we fell in love with that technology and decided to make it into a cloud available platform. The process that we solve starts with raw data streams, so raw data either in Kinesis, Kafka, object storage databases, and ends with tables that are available for analytics in your lakes, in your warehouse. You could say that Upsolver solves the problem of data pipelines, but it's more than just data pipelines because of the tight integration with the data lake. So it's kind of the combination of data pipelines with a lot of the logic you would usually see in a database. Upsolver has been an AWS technology partner since 2018, and we are an advanced technology partner with a data analytics competency. We are the only officially recommended partner for Amazon Athena. As you can see on AWS Athena's webpage, we are service ready for Amazon Redshift, and we've actually been validated technically by AWS as part of their well-architected program. AWS, it's kind of the pleasure to say that AWS has recommended us to customers in many occasions, and we have a lot of satisfied customers as a result, and it was a pleasure collaborating with AWS. Regarding traction, so Upsolver has been in GA since 2018. The product is deployed with thousands of production pipelines. Some of them are at terabyte scale, and the more extreme ones are at petabyte scale and millions of events per second. We work with both enterprises and cloud native companies. AppsFlyer would be a classic cloud native company. And that's it on this slide. Next slide, please. Just to get a sense where Upsolver fits in the AWS ecosystem. So we're exactly in the middle between your data sources where you get your raw streams and the engines what you use in order to actually analyze the data, both lake query engines like Athena and data warehouses like Redshift and Snowflake. Upsolver runs within the customer's own data lake. So we deploy in private VPC, that's the data plane, and Upsolver itself runs on EC2 Spot instances, which is kind of the cheapest way you can find for running processing. All the data that Upsolver ingests or outputs is stored first on S3, and there's a lot of work being done to optimize that storage on S3, exactly like a database does. And Upsolver also manages all your metadata in the Glue catalog or in your Hive meta store. in order to create a table abstraction and not just raw files on S3. Since Upsolver is a cloud service, it has a visual control plane. That's our SaaS, but that SaaS doesn't process any customer data. All the customer data always kept within the customer's own private VPC. Next slide, please. Okay, so let's try to analyze the options that a company with streaming data has when they want to do analytics, and why that's there is a trade-off between cost and basically the ease of use you have to do. And this problem is especially acute when you're dealing with scale. Next slide, please. So there are three options that we see when you want to do analytics on the cloud. One option, let's load all of our data into a data warehouse, put the raw data directly there, and basically go to the traditional 20-year-old process of ELT, of going from raw table to staging table to eventually final tables using batch processing. Some of the tools you can find to do that are dbt or Matillion, for example, used for transformations that run within your cloud data warehouse. The second approach is let's combine a data warehouse with a data lake. Let's use the lake to stage all of our data, run the processing, the transformation processing on the lake itself instead of in the cloud data warehouse, and just load the final tables into the cloud data warehouse, where the cloud warehouse is used for serving the analytical queries. It's not used for preparing the data from raw into tables. The last option, what's called the Parquet table or the data lake table, Parquet being the most commonly known format for open table formats. And then when you're going into the realms of a data lake, your options are to use open sources like Spark for processing, and Upsolver creates an alternative. In a couple of minutes, I'll explain what's the value of that alternative. In this case, you're doing everything in the lake. You get the raw data in the lake and you get your final tables in the lake. Now, let's compare these three approaches and see the trade-off that exists in the market. Next slide, please, Ran. So this is how I think that you can think about it. There are three approaches, and there is a trade-off between the cost it will require to run your analytics and the complexity you're going to have until you can actually have an analytics ready table. The ELT approach is considered considered the easiest, especially when you compare it with Spark, because it's SQL end-to-end. I'm using SQL to run my transformation. I'm using SQL to run my queries. Since it's a database, basically I'm doing a batch process and not a streaming process. Same way we've been doing in the last 20 or 30 years with databases. Then the transformation I'm doing in the queries, I'm running on the most expensive compute. Usually the data warehouse compute will have one more digit per hour compared to running that same compute in a data lake. Comparison between a data warehouse like BigQuery or running processing on something that would cost less than $1 per hour. The second option is the combination of lake and warehouse. In this case, you are able to do stream processing. It's not running on a database. You are able to use inexpensive compute to do your transformation, but you're still running your queries on the most expensive compute possible. The last option is the Parquet tables, in which all parts of the value chain, from raw data to queries, is done within the data lake. And there is a small error there. It says expensive queries, and I meant to write inexpensive queries. So there is a small error there, but that was the intention. The reason that complexity becomes bigger once you go data lake is that usually the go-to approach used to be Hadoop, and today it's Spark. And Spark derived all the complexity of the Hadoop ecosystem. It's basically the same ecosystem. So when I want to do analytics, I'm not writing SQL like I'm used to from databases. I'm writing Java, I'm writing Python, I'm writing Scala, and I need to write that on top of the file system itself. So the databases provide a table abstraction. For me, I work with tables instead of files, but at the same time, everything gets more complex. Next slide, please. And I want to explain why that was a very big pain for us. This is why we invented Upsolver. The idea of losing the ability to run SQL on tables in order to get lower cost doesn't make a lot of sense. This is why databases were invented. People don't want to write code over file system. They want to use SQL on tables. They want to provide access to data to their engineers, to their analysts, to their data scientists, to their product managers. These are all people that know how to work with databases. They don't know how to write code. They don't understand file system. So that trade-off is what Upsolver is looking to solve. And I believe we have also solved it. And if we'll go to the next slide, I'll explain how. So the first step in this value chain is that I have files. This is what I work with Spark. I'm looking at the bucket on S3. I have a bunch of files, and then I'm processing them. What I used to do in databases is work with a table. So Upsolver generates a strongly typed schema on read, and that acts exactly like a table. So my starting point is a table instead of a file. When I run my transformation, I do it with SQL, specifically Upsolver uses a flavor of streaming SQL as opposed to writing code in Java, Scala, or Python. Then the next thing is that I have a whole bunch of complexities that come with the Hadoop Spark ecosystem that databases solve out of the box. I don't need to think about it with databases. I need to index a table to do a join. In Spark, I'm doing it manually. I need to do state management, checkpointing, partition my state. In Upsolver, there is an index spinning up in the background for me. I don't need to think about it. In Spark, I need to orchestrate every step of my pipeline until I reach my final table. So I think the parallel to that is that I run a query on a database. I see the execution plan. The execution plan is generated automatically for me from the database, where in the data lake, I need to actually create the execution plan myself. In Upsolver, all orchestration is completely automatic. You define your source, your transformation, and your target. Everything in the middle is derived automatically. Same goes for all the file system layer. You never need to think about what is the file format, what's the file compression, what's the file size. All of that is taken care of by Upsolver. And of course, the last part is that the data lakes are missing some capabilities, especially around append only. So data lakes tend to be append only creatures, and Upsolver is turning them into tables just like in a database. So you can upsert, you can delete. On vanilla Parquet file, you don't need to go to specific file format. You can, of course, that's also possible if that's what you want, but you don't have to. You can get those capabilities for vanilla Parquet tables. These are the reasons that I think each one of these lines explains how we are applying database language, database interface into the data lake to make it easier. So you get the same complexity for a solution that can cost you 60, 70% less compared to a cloud data warehouse. Next slide. And I'm gonna hand it off to John. I'm happy to take questions after John and Avner are finishing with their part.
Thanks, Ori. Hi, everyone. My name is John Williams. I work in the advertising and marketing technology team at AWS, looking after customers in the MarTech, AdTech, and agency business line space, helping them innovate their businesses as they shift to the cloud. What I thought it'd be useful to do today is think about how we think about the world in terms of observing trends in the marketplace, and then looking at AWS technology that can resolve the challenges for marketers via our customers and partners that collaborate closely with companies like our friends Upsolver to enable them to save time and money for companies such as AppsFlyer. I'm just going to quickly look at some of those trends, talk about the solution areas that AWS is developing, and then hand over to our partners to walk through some of the compelling case studies they have. So here are the macro trends and challenges that the current market faces in digital advertising. So if we look at Customer 360, marketers and publishers now must gather, store, and unify unprecedented volumes of first-party data for personalized one-to-one advertising in a cookieless era. Privacy-safe data sharing and enablement, industry leaders are developing new interoperable standards and analytics capabilities to share cookie identifiers for personalized advertising measurement and attribution. Analytics and data science. There's exponential growth in data and new sovereignty laws, increased complexity for performing identity resolution, audience segmentation, inventory analysis, and attribution. Activation via advertising, as new inventory paths open, performance, cost, and latency requirements grow more demanding for advertising platforms executing millions of ad transactions per second. And then commerce and customer experience. Consumers are demanding personalized omnichannel experience along with high standards for data privacy and service. You go through to the next slide. As a result of those challenges, my team is focused on these areas of business solutions: first-party data platforms, data sharing interoperability, advertising intelligence, advertising platforms, and Amazon advertising integrations, and then CX. But for the purposes of today's call, we're really going to focus on the first 1 and 2 segments. So first-party data platforms, i.e. Upsolver, and then the work they do to help the advertising intelligence partners, such as AppsFlyers, that live in the advertising intelligence space. If you go through to the next slide. As Ori was just talking about, marketers and publishers must now gather, store, and unify unprecedented volumes of first-party data for personalized one-to-one advertising in a cookieless era. They're particularly challenged with the management of up to 20 or more different work streams on e-commerce, website, clickstream, mobile app engagement, sales performance data, ad performance data. And 80 to 90% of their time is spent keeping these streams up and running versus interpreting the data to respond in real time. And the reason that we're so excited about the partnership that we have with Upsolver, the AWS data and analytics technology partner, is the opportunity that they give for companies to realize immediate value from all of the real-time event streams and big data sources. It powers machine learning for real-time data in a cloud-native solution that was envisioned, built, and validated on AWS. And the solution provides a single visual platform via AWS Marketplace for preparing both historical and live data, and enabling engineering teams to offload repetitive data engineering tasks. Streams are ingested into Amazon S3 and stored ready for exploration and model training in SageMaker, Athena, or Spark. And Upsolver materialized views enables you to run these models on real-time data with just a few clicks. You go through to the next slide. And so we see customers looking to build scale customer data platforms as a service, wanting to be able to choose from the broadest capabilities of data lakes analytics to create highly scalable, cost-efficient platforms. And we're really excited to hear how Upsolver worked with AppsFlyer's data lake architecture and unlocked scale and performance with them while working with massive data sets to dramatically reduce the cost compared to their previous data warehouse implementations. And with that, I'll hand over to Ori and the team to talk to AppsFlyer.
Hi, everyone. I'm Avner Livnen. I'm the RTA team lead in AppsFlyer, one of the RTA team leads in AppsFlyer. RTA is a real-time attribution group. Basically, that's the core group that was first introduced in AppsFlyer, and entire product set was set around it. So next slide, please. So let's first talk about what we do in AppsFlyer. AppsFlyer is a leading mobile ad attribution and marketing analytics. We provide our advertisers a great tool for doing business intelligence around what the campaign do over time. We drive the best result. We give brands a holistic view of every journey across platforms, channels, and devices. Next slide, please. Okay, let's give some numbers about the AppsFlyers. We have more than 1,200 employees in total, and we grow fast. All our stack is in Amazon Web Services, and we are currently one of the biggest clients of Amazon Web Services in Israel. Our traffic is around 120 billion events per day, and our SDK is installed in over 95% of all mobile devices out there. So good chances that our SDK is at least installed 20 times on each of your device of any of the attendees here in the webinar. The backend is written mostly in Clojure and some Golang and Scala. Next slide. Okay, before Upsolver, so let's take a step back. We have a huge data lake for support purposes, and we have many support people and product guys and some data scientists that work with it on a daily basis. And up until Upsolver a year ago, more or less, we had an in-house ETL written in Clojure, and the cons were very clear all along the way, where we had a huge engineering overhead maintaining that ETL. Data transformation were very hard, schema changes were hard. While it was functional, it was everything about the inside the in-house ETL was requiring a lot of attention and engineering, and also high costs, because ultimately it was not tuned to be for optimal tuning. Next slide. So the solution we did was replace it with Upsolver. Basically, we have tens of, or more than tens of services generating raw data into the data lake. We are talking about petas per day of data streaming with from multiple nodes, Upsolver nodes, streaming to S3 and into Athena. And then we have two major use cases that we operate on. We have some third-party tools that are generating queries and generating alerts based on Athena queries, Athena predefined queries. And we have a team of support personnel which work day and night against the Athena with the ad hoc queries to figure out problems that we have, or any other interesting KPIs that we are looking in the data. Next slide. The benefits were very clear right at the beginning. First of all, the adoption went very smooth. We had little issues. We just created a new bucket, moved the topic to write to a new bucket, and switch the support guys gradually to the new bucket, while maintaining the old one until the move was complete. So the first thing we noticed that it was a significant cost reduction. The Upsolver engine was far more efficient than in our CTL, just for the compute cost. The second thing we noticed right over also pretty immediately is the engineering hours. We saved tens of and hundreds of engineering hours of data engineers working on the in-house ETL. The adoption was really fast since everything is inside the UI, and it's pretty clear. The schema is very clear to us, and you can see and manage it very efficiently. Applying new schema is very, very easy. Some side benefits was we got off our shoulders a big monitoring overhead. So the monitoring of the flow of the stream that we are moving into Athena was practically moved to Upsolver, and now we have some kind of I would say guardian angel that sits over there and alert us if anything goes wrong. And to be honest, this is very we find it very assuring. So I did mention the web UI was great, because after the adoption of the Upsolver stream, we started digging into the data, since it was no longer a black box that moved tons of petabytes. We actually saw places where we can trim long records and figure out way to manipulate the data to reduce the size of the tables that we create. Another thing that we tried and was very helpful, the ability to replay data again. Well, actually, it was also possible in the old ETL, but doing that was really risky and error prone, and here the replayability was great and worked saved us some hours and a lot of pain, I guess. And the last and most and another important key here is the fact that it's deployed inside our VPC, and the data is not leaving the AppsFlyer ecosystem. Next slide. So some features that we like the most. Everything is automated, managed. There's no need to worry about compaction or duplicates or everything. Everything works very, very, very smooth. We are running for now almost a year now, and we enjoy the stability of the flow of the Upsolver flow is very impressive, in my opinion. One funny thing is that I was talking one day to the Upsolver guys. I told them that I really don't need them anymore because everything just works. So there's that. Another thing is the ability to optimize the queries, reduce costs with the UI. The replay was very useful for us in a couple of occasions where we have to replay some data that was corrupted for some reason. And the SQL-based functionality that allows you to really easily reason about what you move from one side of the stream to the other. Last slide.
Yeah, I think this is our last slide. Okay, thank you very much, Avner, and as well as Ori and John. I think we have a few questions, so we can go on to answer these now. Right, so our first question is, we have two questions for AppsFlyer. One is the performance of Athena. I'm assuming in the new architecture, where you've offloaded some of the old BigQuery stuff to Athena. So the question is, how is the performance you're seeing from Athena?
Well, we carefully partitioned our data, and we did a careful analysis before adopting Upsolver. Basically, we knew how to partition the data because we knew Athena. Well, we moved from BigQuery, and BigQuery is slightly more faster than Athena, but if you partition the data correctly, I think it's cost efficient. There is certainly better to go to Athena. The cost of BigQuery doesn't worth the waiting a few seconds less, in my opinion. Do
you have a way to quantify that cost in there? Do you know what was the cost reduction on the compute side?
I don't really have the numbers, but I know it was very very high. We're talking about tens of thousands of dollars so far.
Eran, one thing to note is that, and that might be a little confusing, but both BigQuery and Athena charge $5 per terabyte processed. But the difference is that Athena charged those $5 for compressed data, and Google charges for uncompressed data. So basically, the compression ratio is the difference in query costs between the two engines, and that's a pretty significant difference.
Yeah, and I believe that we have a few kind of resources and benchmarks that we ran on Athena versus BigQuery in terms of both performance and costs. And yeah, that's what we were seeing as well, that kind of the way you prepare the data can really bring Athena to very similar performance at a fraction of the cost. So we've got another follow-up question on that is, did you look at Redshift as a comparison?
You asking AppsFlyer?
Yes, I think this is for AppsFlyer. Yeah.
Well, I don't really know the comparison that was done. So I can't answer this question, unfortunately.
Okay, that's that's good. So we have a few more questions. I think this is also for AppsFlyer. So do you have a similar use case, I'm assuming on the same data, that would require a high concurrency of queries? And would that other workload require other tech rather than Athena?
Yes, we have many other workloads. We use Spark heavily, but that is a different use case, because we are talking about streaming data into a very complex streaming orchestration, and we still, it's not in my domain actually, because I work in the real-time attribution and not in the analytics team. So we have a lot of Spark batch processes. Yeah, if that answer the question.
Yeah, I believe so. So one more question. So we have a few more questions. So one is, do you use Upsolver to do the data compression, which is usually done by Spark?
Yes, we do. The data is compressed, and yep.
Yeah. Or do you want to maybe expand on Upsolver's data compression capabilities?
Yeah, sure. So I think one of the big challenges that we see is joins, usually especially with customers that have lots of data. And in order to do such a join, usually would need to partition your state across many instances, require a lot of low-level engineering. The other option is to add a key value store like Cassandra or Aerospike or Redis, and then you have another database to manage as part of your ETL. What Upsolver is doing is basically implementing the concept of an index, but it's in a decoupled index that's stored on S3, being inserted from memory. And in order to do that and fit more data in memory, we're able to create a technology that compresses data using columnar level compression, which is the most efficient, but you're able to extract a single value by key without uncompressing the data. And that's something that no other key value store in the market can do. So you're basically able to keep 10 times more data in memory in comparison to any other technology. That's kind of in the very deep parts of Upsolver, but that's a big part of the technology differentiation the company has, and it powers most of our unique capabilities like metadata management for all your data, upserts, high cardinality joins, and so on. There is a blog about it called Lookup Table, the decoupled version of Cassandra. So you can Google it and see exactly how it works.
Right, but just to be clear, on S3, the files are stored as kind of an open source Parquet, and the compression.
Yes.
Yeah. Right.
Exactly. Just the indexes are the proprietary parts. Just the indexes. The data itself is always in vanilla Parquet. Open formats is is the basics for us. We don't do anything that's not based on open formats.
Okay. So one follow-up question about that. So basically, how does Upsolver handle the streaming data process, which would also usually be done in Spark?
So everything around the Upsolver processing engine is incremental. So we always process only a single event. But in order to actually do something meaningful, we need to add historical context into that event. That is being done exactly with those indexes I just mentioned. So they allow us to pull historical state, basically for all your data lake, and join it with the single event we are currently processing. So I think the efficiency here comes from the single event processes with the indexes, as opposed to Spark. It's kind of based in most cases that we see, there is this streaming in Spark. Most cases that we see, there is batch, and state management is usually something that only the data engineers can do.
Okay, and we have one or two last questions for now. One is, I guess, for AppsFlyer. which is, did you look at Upsolver's, did you look at the need for using Upsolver's Presto implementation? So I guess, are you, I mean, I'm not sure I understand, but I think the question is, are you using some open source Presto or only Athena?
I believe the answer is Athena.
Yeah.
The question you were a little bit cut off. So the question is, did we look up on Presto to bake an in-house Presto? That's the question.
Yeah, if I understand correctly, yes. Can you? Are you with us over there?
I think something is wrong with
internet connection is a little off.
Maybe I got a bit of a connection issue. Okay, so we will, if we need, we can get back to that later. But to the best of our understanding, it was only kind of Athena and not open source Presto. But if you are interested in more details about the Upsolver's Presto implementation, then I'll be happy to send some video resources about that after the session. We have a talk that our CTO gave at PrestoCon. Thank you, Avner.
Eran, maybe one comment on the open source Presto. Since Upsolver doesn't write to Athena directly, we write data to S3 and metadata to the Glue catalog. So you could use open source Presto in parallel to Athena, in parallel to Redshift Spectrum, in parallel to EMR to query the same copy of the data. So once you go with an open format like Parquet and you use a centralized metadata store like Glue Catalog, the decision of which engine to use becomes much easier because you can switch between them without doing any migration like you would do in a database.
Okay. Thank you. So the question about that is, would Presto be faster than Athena?
It's the same. Presto is Athena.
It depends on the cluster you use. So Athena is a multi-tenant service, of course, and open source Presto, if you create a large enough cluster, you can get better performance, but Athena gives you a lot of resources and you don't need to keep them up and running and accumulate a lot of cost. So in some cases, Athena is a great fit, but I've seen customers with high scale and high concurrency of queries saying, hey, I'm going to use EMR to do on this workload because I want to keep my own warm cluster at any given time.
Okay, we have one other question around data freshness. Like, what were your requirements for data freshness in the architecture that was presented? So the answer to that is around 10 to 20 minutes, which I assume that's from the moment the event was created.
Yeah, it's from the moment we hit the event hit AppsFlyer web handlers until it reached the data lake. Actually, it takes seconds, but our requirement was like 10 minutes was good enough.
Okay, understood. Okay, I think that's all in terms of questions. We will be sending a recording of the session after the event. If there are any additional questions, you can reach out through our website, or you can email info@appsolver.com, which is also the address you'll get the follow-up email from, and we'll be happy to answer any questions directly. Otherwise, thanks everyone for joining. I hope you're having a pleasant week. For the people in the US, I hope you enjoy your upcoming time off for Labor Day. Yeah, thank you, Avner, and thank you, John, for taking the time to participate. It's been really interesting, and yeah, hope to see you all soon again.
Thank you, everyone.
Thanks, everyone.